Good evening, welcome. So I have, I'm told, 45 minutes and 55 new features to get through. So this is something of a challenge. Hopefully, I'm going to give you enough information about these features so that when we finish the presentation, you can go and look at them in a bit more detail, because clearly I can't go into all the detail necessary for all 55 new features. Now, JDK 9 is scheduled to come out on the 26th of July, which gives us, what, about 3 months? No, June, July, 2 months, just over 2 months. I'm still fairly confident that we will actually meet that date. There are a few things going on. I'll mention those as we go through, but I'm still fairly confident that we will actually see JDK 9 at the end of July. Okay, now. Okay, let's try that. Right, so I've divided this into a number of sections, first of which is major features. And clearly the biggest of those is the introduction of the Java platform module system, modularity, and Jigsaw. Now, those of you who follow the sort of news about this may have seen that last week there was a vote on the JSR for Jigsaw. And a number of people in the JCP executive committee voted against that particular JSR. So people are all going, "Ooh, what's going to happen with Jigsaw now?" People have voted against Jigsaw. Well, that's actually not quite what happened. What happened was there was a vote for the public review of the specific JSR, which was 376. And so more than half the people on the executive committee voted against it. But what that means is it gives the spec lead, Mark Reinhold, and the expert group another month to come up with some more changes, because there are still a number of issues around Jigsaw, but it doesn't mean Jigsaw's dead. Does not mean that Jigsaw is going away. It's still very much part of JDK 9. Now, in terms of what's happening with Jigsaw, I'm not going to spend very much time on this because this is kind of the big feature, but there's lots of other ones to go through as well. What modularity means is primarily breaking up the JDK itself into a number of modules. Up until now, we've had one big rt.jar file. Started out with 200 classes back in JDK 1.0. JDK 8, it's about 4,500 classes. So breaking it up into more manageable chunks makes a lot of sense. So if you look, there are now 94 modules that make up the JDK. One of the big changes that's happening around this is the fact that many of the private APIs that have been used to develop the public APIs in Java are now being encapsulated, which means you don't get to see them anymore. Things like sun, misc, unsafe, which is probably the most famous or infamous of those. Now, a couple of things have been done to try and smooth the process of migration from JDK 8 and no modules to JDK 9 with modules. There are a couple of command lines, add add exports and add opens, which allow you to say, well, okay, I know I shouldn't have used these things, but I did, so I'm going to make them available even though they have been encapsulated. You can still get access to them either through importing them or specifically through reflection. So there are ways of getting around this to enable you to have backwards compatibility. Obviously, there are a few issues around this in terms of libraries, things like Maven, various things that are being worked through. This is really the big changes that are happening at the moment. If you follow the Jigsaw mailing list, there's things like how to name automatic modules has been changed recently. There's still some discussion going on about how to use automatic modules and including information in the jar manifest rather than just using the name of the jar as a way of defining what you're using as an automatic module. What you can do is you can leave your application and have everything still on the class path. So you can, in effect, ignore modularity. If you leave everything on the class path, so long as you have not used any of the internal APIs, the non public ones, then your code will run without any changes. Once you start moving to the module path, things get a little bit more complicated. You need to make some changes, perhaps, but there are various things you can do around that. But it allows you to take an existing application, don't change anything on the command line, and so long as I say you don't use any of the internal APIs, it will run on JDK 9. One of the more recent changes was the big kill switch, which was introduced. And this is another command line option, permit illegal access. Great name for an option. Permit illegal access, which in effect turns off most of modularity. So it turns off all of the encapsulation, so you don't have to worry about reflection and things like that. Right, so let's look at some other things. This is sort of related to modularity. There's the idea of JLink. JLink's a new command which was included in JDK 9. And what it allows you to do is to build your own runtime for Java. But the idea is that you can say, well, rather than taking the JRE that we used to have and then adding in jar files that we have for our application, we'll actually build a runtime which contains only the modules that you need from the JDK for your application. So if you're not using things like Corba, if you're not using things like the desktop, for example, those modules get left out. So the only modules that will be included in this runtime are certainly java.base because it has to be there. And then if you're using, let's say, java.sql, java.logging, java.xml, things like that, those will be included in the runtime. And if you do something like this where you say JLink with a module path and you just add java.base, when you run the Java executable that's created in the file system for you, what you will see is that there's only one module, java.base. Now, that's not going to do anything particularly useful, so let's look at another example here, where we've got a sort of sample app which uses some modules. And if we say that we want to link that, all we have to do is provide the application itself, the compiler will work out all of the dependencies from the modules that have been defined. We will see that when we list the modules, we see java.base, logging, SQL, XML, and then some app, Zoop, Zeta for the application. Now you'll see also there's some extra information there, which is at 9.0, at 1.0. And you may be getting excited. You may be thinking to yourself, oh look, we get versioning in this module system. Do not get excited. There is no module versioning in Jigsaw. In fact, version numbering here is just for information purposes only. It doesn't actually have any effect on how different versions of different modules are used. And in fact, I've even quoted here from the state of the module system, it is not a goal of the module system to solve the version selection problem. So this is something that people have kind of argued against. There are other module systems out there which do support versioning. Jigsaw in JDK 9 does not. So that's something you just have to accept. Other things outside of Jigsaw, what other things are we starting to see as sort of more major features? Well, one of them is factory methods for collections. And if you look at the collections API that we have at the moment, we have set, we have map, we have list. That's all very good. But the problem you have is if you want to create an initial set of values in your collection and you want to make it structurally immutable, meaning you can't change the references to the objects in your collection, then you have to write quite a lot of code. The idea behind this is to simplify that. So there have been a number of new methods that have been added to the collection interfaces, so map, set, and list. And the way this has been done through static methods. Great thing with JDK 8 was it introduced the idea of being able to include static methods in interfaces. So we've taken advantage of that, and we can now add some methods to the interfaces for these collections, rather than having to add the necessary methods in all the different classes that implemented those interfaces. What you'll find are there are 11, actually there's 12. There are 12 methods that have been added to each of those interfaces. The first 11 of those allow you to create a collection with 0, 1, 2, 3, and so on, all the way up to 10 elements. So there are overloaded versions of those methods for 0 to 10 elements. And then if you want to go beyond 10, there's another version of the method which takes a varargs parameter. So what it will do is allow you to pass as many parameters as you want. But for some reason they've decided to go from 0 to 10 as fixed methods, and then there's an arity method or varargs method which allows you to add an arbitrary number. And so if you look at an example here, this is how we would do it in the old days. So we create a hash set and we would add things to that, and then because we want to make it immutable, we have to set that to be unmodifiable, an unmodifiable set. And if we change that to use the new JDK 9 code, it becomes a lot simpler. We simply say set.of ABC, and we get one line of code, and it looks a lot neater, a lot tidier. Streams were introduced in JDK 8, and they proved very, very popular. So a few things have been added in terms of the Stream API for JDK 9. Two significant methods are called drop while and take while. And the way these work are very similar to the existing skip and limit methods. So skip and limit allow you to say, I don't want to take the first n elements of the stream, but I do want to take the rest of it. Or I only want to take the first n elements of that stream and then ignore the rest of it. To do that, you pass an integer. So you pass a number which tells the stream how many elements to either skip or to deliver before stopping. What take while and drop while do is the same thing effectively, but rather than using a number to indicate when to start or stop taking elements from that stream, it uses a predicate. So in effect, you've got an if statement. So you can set a condition so that you keep taking elements from that stream until that condition is met. Or you drop elements from that stream until the condition is met, and then you start taking the elements from that. One thing you do need to be a little bit careful of with there is if you're using an unordered stream. That way, you may run into a problem where you actually end up ignoring elements that would have been passed because your predicate only needs to be satisfied once. So you could say, okay, drop while this is true, not true, get to the point where it is true, but then there are some elements after that which would have changed the state. So it's just something to be aware of if you're using an unordered stream. The iterate method has been improved. In JDK 8, there's an iterate method which only takes one argument. Now in JDK 9, there's an iterate method that takes 3 arguments. And the idea behind that is to give you the same way of defining an iterate, or an iterator, I suppose, which looks like an existing for loop. So if you think of the syntax for a for loop, we have the initial value, you have the test to determine when that loop finishes, and you have the thing that happens every iteration of that loop. The iterate method now has a version which takes 3 lambda expressions, and you can define, in effect, the same as a for loop. The files.lines method is now parallel, or able to process things in parallel. And this is very useful from a performance point of view, because if you are reading lines from a file, and you tried to use a parallel stream on that before, you would actually get worse performance than if you used a sequential stream. Reason being that obviously a file is read sequentially. And by doing that, when you try to do it in parallel, you just run into all sorts of problems. What files.lines does now is it memory maps the whole file, puts it into memory, and then divides it up into a number of regions based on where the line breaks are, in order to try and get you roughly equal chunks for the file. Now, because of where the line breaks are, it may not be exactly equal, but by doing that, it means that multiple threads can read lines from those different sections in parallel, and you get much better performance. There is now an optional method which returns a stream. So if you've used optionals, which encapsulate a value, either a null reference or a valid reference, you can now get a stream from that which returns either 0 or 1 element. 0 elements if it's a null, 1 element if it's a valid reference. And then you can use the same ways of processing that stream as if it's any other kind of stream. Multi-release jar files. So this is sort of related to the idea of modularity. So having said that modularity is not going to deal with versioning, we are going to have multi-release jar files. The idea of this is that you can have different, I'm going to use the word, different versions of your code which relates to different versions of the JDK. So even though you are not dealing with versioning in the sense of having a number associated with it, what it allows you to do is say, okay, I need this particular set of classes if I'm running JDK 9, this particular set of classes if I'm running JDK 10, and so on. Obviously, at the moment, that's not really a whole lot of use because you have to start somewhere. So at the moment, we support JDK 9. So you can have one version in your jar file. Once we get to JDK 10, you can have two versions in your jar file. But right now, it's sort of setting the line where we will start from here. A few things that were changed in terms of supporting that, things like the class loaders, things like the jar file API, the tools that use jar files, like Java-C, Java-P, JDEPs, etc. All of that had to be changed. Same with modular jar files. REPL, or JShell. The idea behind this is there's two things really. One is to help you when it comes to prototyping code. And so if you're kind of trying to figure out how a particular bit of code works, and you don't want to have to build a whole class and then sort of write some test framework around it and various unit tests, what you can do is you can fire up JShell, and then you can just write the little bits of code, the snippets of code that you need, and see what values you actually get. When I first saw this, I thought to myself, well, yeah, okay, that's kind of interesting, but I don't see myself using it a lot. But I actually have found that I have used it quite a lot, because, as I say, there's times when you think to yourself, okay, so how does this little bit of code work? And rather than having to actually go into the IDE and then sort of, like I say, create a class and write some unit tests, you just go through and you say, okay, create me an array list of strings, right, wonderful, add hello to it. Oh, hang on, there's a null pointer exception there. Right, yeah, okay, I need an array list and I need to assign something to it. So I need to create an instance of the class. Then you can add something to it and then find out what it is. So simple things like that. The other big idea behind this is to lower the bar in terms of learning to write Java. A number of universities have started to sort of move away from using Java as their primary teaching language because of the fact you have all this sort of overhead of starting up the IDE, you've got to have a class, you've got to have methods within that class, and so on. And this makes it a whole lot easier. So if you're just interested in learning the syntax, just interested in seeing how a for loop works, how a while loop works, how different methods work in different libraries, this is a really good way to do it without having to write a whole lot of extra code. So the idea is to sort of help people when it comes to learning Java and make it easier when you're trying to experiment with little bits of code. Concurrency updates. Now, if you go way back to JDK 5, the concurrency libraries, the concurrency utilities were introduced. And this was all about trying to make life easier if you're writing multi-threaded code and you want those threads to cooperate. You want them to work together. We had all sorts of classes introduced, things like semaphores, things like atomic operations, rewrite locks, mutexes, and so on. And over time, we've gradually added more features to that. JDK 7 introduced the fork join framework. JDK 8 gave us parallel streams to make life easier from that sense of view. But what we've done in JDK 9 is to add some new features around a couple of areas. Now, one of those is the idea of having reactive streams framework. This is something that's become very popular recently, especially with sort of web applications where you've got lots and lots of clients all trying to access your server simultaneously. And so you want to be able to handle those requests asynchronously, you want to be able to handle them in parallel and do it in the most efficient way. So what happens with JDK 9 is there's a new set of classes which are related to flow. And this is the reactive framework they've created. So you've got a publisher, you've got a subscriber, you've got a processor, and a subscription. The idea behind this is that your client acts as a publisher. So this is actually the client for your web application, say, acts as a publisher because it wants to use the service. So what it's going to do is it's going to send messages to the service. And the service on your server is going to be a subscriber. So it's a little bit sort of, when you look at it, first of all, you think, well, hang on, that's the wrong way round. But it's actually the client, which is the publisher, and the server, which is the subscriber. So it says, I can handle this number of events from clients at this time. So the publisher then knows, oh, okay, I can send this number of messages to that server without it getting overloaded, and it will send that many messages. If it needs to send more, it has to figure out how to deal with that. So does it send it to a different instance of the server? Does it wait? It's up to it to figure out how to do it, but it knows how many messages it can send without having problems of buffering or blocking on sending those messages. The way that publishers and subscribers are linked is through a subscription. So the subscription, in effect, defines how many messages can be processed by the subscriber from the publisher. There's also a submission publisher utility class, which gives you a few nice methods that allow you to essentially send messages from your publisher to your subscriber and deal with all of the sort of bits and pieces in there. So it's an interesting way of handling a reactive style of programming. The other thing that's been modified in terms of JDK 9 is the completablefuture class. This was introduced in JDK 8. Changes here not so terribly major. Essentially what the changes here are around dealing with timeouts, dealing with delays for how that completable future actually works. So there's additions of delays and timeouts. There's also better support because a lot of people tend to subclass the completable future, so that's also been improved. There's a couple of new utility methods that are included, so there's things like a minimal completion stage, there's a failed stage, and two methods that I particularly like, which are new incomplete future and failed future. So just as a thing there, you can have a failed future. Deprecation. Right, deprecation goes all the way back to JDK 1.1 when the javadoc tag was introduced at deprecated. And that allowed the developers of the library to say, well, these particular methods we don't think you should be using anymore. And that way you could sort of go through and you could be alerted to where a particular method that you were using or class or whatever was likely to be removed at some point in the future. Of course, up until JDK 9, absolutely nothing has been removed from the Java class libraries. So even though there are many deprecated classes and methods and interfaces and so on, none of them have actually been removed until now, as we'll come back to in a moment. JDK 5 introduced annotations, so an annotation was introduced for deprecation. That has been enhanced in JDK 9, so now you can actually get more information about something when it is deprecated. There are two methods in the deprecated annotation that have been added. The first is a Boolean, which says for removal. Now this might seem a little odd, but there are methods that are being deprecated which are not necessarily going to be removed. It's just that there's a better version that you could use. The idea here is that if you're using that particular method, you can go, well, yeah, okay, so it's not going to be removed, but I'll keep on using it because it avoids me having to change my code. But I know I don't have to worry about it because it's not actually going to be removed at some point in the future. If the for removal method returns true, the idea is that in the next release, that particular method will be removed. And then there's also a string that you can retrieve related to a deprecation annotation, which will tell you when that particular method was deprecated. So I'll give you more information about the timeline in terms of which JDK version it was. Several places, deprecated tags have been added. So if you look at, oh yeah, there's actually somewhere they've been removed. So Java AWT component show and hide were deprecated. Now they're not. And then there's also another new tool which is introduced in JDK 9, which is called JDepreScan, which will take a jar file and actually scan it to see whether you're using any deprecated APIs and give you a nice little report. So it's a useful sort of tool to to run just to see if there are things that you're using that have been deprecated. Project Coin. Project Coin came along in JDK 7, if I remember rightly, and that added a few small features to the programming language. So this was things like strings in switch statements, the try with resources way of doing things, various things like that. And what's happened in JDK 9 is that Project Coin has been extended a bit. So there are a few more small changes to the language. First of those is that a single underscore is no longer going to be valid as an identifier. Hands up anybody who's used a single underscore for a variable name. Okay, a couple of people at the front here. I'll talk to you later. It's okay. Actually, even though a single underscore can no longer be used, don't worry. All you have to do is make it a double underscore, and it's valid. In fact, any number more than 1 is valid as a variable name. The reason for taking that out of circulation is because in JDK 10, the idea is that a single underscore will be a valid identifier that you can use in a lambda expression. And that does make sense, because if you have a lambda expression where you have a single variable that's not used in the body of that lambda expression, using an underscore kind of hides the fact that you've got a variable there. So it's just a sort of syntactic way of hiding things. Private methods are now going to be allowed to be used in interfaces. As I said, in JDK 8, with the introduction of default methods and also static methods in interfaces, we now have multiple inheritance of behavior in Java. Because we can put behavior into an interface, private methods actually make sense. So you can have private methods where you can sort of take common code from a number of default methods or a number of static methods and move it into private code that can't be accessed outside the interface. Effectively final variables in try with resources. Now, again, what you've had to do up until now is if you use a try with resources block, everything that you want to reference has to be assigned to a new variable instance in that try block. That doesn't always make sense, because if you defined a variable outside of that try block, you should be able to use it inside the try block. But you still have to, up until now, assign it to a new variable name. With the changes in JDK 9, that's been altered slightly. So if you have a final or effectively final variable that's declared outside of the try block, you can use it in the try block without having to actually assign it to a new variable instance. Safe varargs on private instance methods. This is a small change which is being made in terms of how type inference is used. Actually, no, not type inference. It's how inheritance is used. Yeah, sorry, I'm getting ahead of myself here. So safe varargs, you can use safe varargs to understand if there's a place where you might get a warning which actually doesn't make sense, because the compiler looks at things and says, oh, you know, this could be a problem, but you know it's not because of the way that the code works. So at the moment, you can use safe varargs on constructors, you can use it on final, and you can use it on static methods. None of these can be overridden in subclasses. And since a private method can't be overridden in the subclass, it makes sense to also add that to the list of things where you can use the safe varargs annotation. So that's the reason for that. Diamond operator with anonymous classes. This is where type inference is being extended. What happens here is that there are situations where you can have a diamond operator with an anonymous class where the compiler can determine what the type is in a representation that's understood by the compiler, but it can't represent it to the virtual machine because of the way that it's defined internally. So to avoid that problem, you couldn't use the diamond class where you allowed the compiler to infer the type for you with anonymous in classes or anonymous classes. In JDK 9, they've relaxed that a bit. So long as the compiler can resolve it to a type which can be understood by the JVM, then you can use the diamond operator with an anonymous class. So again, fairly small change in that respect. Standards. There are a number of standards which have been updated in JDK 9. So the first of those is Unicode. Since JDK 8, there have been two major versions of Unicode, Unicode 7 and Unicode 8. Now, when I looked at this, I thought, right, I'll actually dig into this bit and find out what's going on. So Unicode 7 adds 2,834 new characters. Unicode 8, they found another 7,700 characters that they hadn't referenced before. So I thought to myself, where are all these characters coming from? I mean, what is it that they're finding which they need to represent in Unicode? Anybody want to guess what the big thing is? Emojis, exactly, yes. So one of the big things they're adding is lots of emojis to Unicode, which kind of has some interesting things we'll talk about in a moment. Also, interestingly, in Unicode 8, there's the introduction of, let me get this right, lowercase Cherokee. They had uppercase Cherokee, but now they've added lowercase Cherokee, which is Native American language. So, okay, well, if you want to do lowercase Cherokee, now you can in Unicode. Other things that have been updated, things like the public key cryptography standard 12 key stores is now been upgraded. The Java docs now use HTML5. Great, get some nicer documentation. And the SHA3 hash algorithms have been updated to try and keep us ahead of the hackers. A few smaller features related to this. So we can now use UTF-8 for property files. Now, the big thing about that means that you can use Unicode for your property files, which means you can use emojis in your property files or lowercase Cherokee in your property files. A few things that were updated in terms of that. Resource bundle API needed to be updated to use that, so that was okay. There's this other weird thing here, which is called the DRBG-based secure random implementation. And this is a deterministic random bit generator. Now, to me, that seems like an oxymoron. Deterministic random. Well, either random is non-deterministic or it's not random. But anyway, so we have this new way of generating random bit patterns that can be used. And there's an update in terms of the XML catalog API. This was an API that was designed by the Oasis people, and you can use it with JAX-P. So that's, again, an update in terms of the version of the API that's being used. Things changing inside the JVM. Right, the default collector is now changing. Rather than being the parallel collector, which is what you would get by default on a server class machine, a server class machine is defined as one that has 2 or more cores, 2 or more gigabytes of memory, and isn't running Windows, then you would get the parallel collector. Now you get G1. G1 has been around for quite a while. They've done quite a lot of work on it. It's designed very much as a low pause collector, but it may be something that if you're running your applications at the moment, you have a particular profile you're interested in for performance, that when this changes, you might want to look very carefully at what's actually happening in terms of the performance of your application, because things will change. This still does have the drawback that it uses stop the world pauses, and it does fall back to a full compacting collection if it can't keep up with the rate of allocation in the old generation. In fact, everybody does that except for us at Azul. So this is my kind of one marketing sort of slide here, because we have a Zing JVM which uses a pauseless garbage collector. So if you really do want low overhead in terms of your garbage collector, Zing is the thing to look at. Better string performance. A couple of things that are being done internally in the JVM to improve performance. So one of these is the idea of compact strings. It's more about looking at how efficiently the space is used internally. So it's not actually looking at compressing the strings. It's not actually using like zip or compressing them in some way. It's just looking at how the strings are stored internally and optimizing the space that's used. So if you've got multiple copies of the string, then you only need one of them. Same thing in terms of using intern strings, in terms of the way that data is stored, so that you can actually share strings between multiple JVMs. If you're running multiple JVMs on the same machine, then there is a way now to actually share that data between them to avoid using up extra space storing the same string. And then there's some work that's been done in terms of improving the way that string concatenation works. And this uses the invoke dynamic way of doing things, so that the way that the string concatenation happens isn't defined at compile time. It's actually left so that the JVM can look at the most effective way of doing things and using intrinsics, maybe using the hardware architecture, better use of cache lines, things like that. But it allows the JVM to take decisions about how to do string concatenation in a more efficient way. The Marlin graphics renderer has been changed. Now, what happened here was that if you look at OpenJDK, which is the source code base for the JDK, there is an open source version of the graphics renderer that's used for desktop applications. That's the green line, which you see sort of at the top there. And higher up means worse in terms of this particular performance graph. If you look at the hotspot JVM that you get from Oracle, they use a different, they actually used the commercial one, so it wasn't open source, and it was called Ductus, if I think. Yeah, Ductus is the commercial one. And then what's happened is that the graphics rendering engine has been rewritten as another open source version, which is called Pisces. Marlin. I get them right way around. So Marlin is the new one, and that has pretty much the same performance profile that you get with the commercial one. So it just means you get better performance in terms of graphics rendering. Smaller features, improved contained locking. So there's this is again sort of very internal to the JVM. You won't see any difference from the point of view of your programming, but what it does is does some reordering of the way fields are accessed in order to optimize the use of cache lines in the processor, so you get better performance out of it that way. It's also using machine instructions at the processor level to improve the performance of some of the cryptography APIs. And what we've seen is that you get somewhere in the region of, well, depending on what test you're running, this is 34 to 150 times better performance in terms of encryption and decryption using this way of doing things. If you're using JavaFX, there's a new version of GStreamer that's being used to support the media class, so better security, better stability, better performance in that respect. Other things, segmented code cache. So now again, internal to the JVM, things that are happening to improve performance, separating non-method profiled and non-profiled code. So very low level, don't really need to worry about it, but it makes the performance of certain applications better. What is a bit more visible is the way that logging happens now. So there is a unified JVM logging system that's being used for all the components of the JVM. So you get better representation of the logging messages, easier to sort of pull out what you actually need. And in support of that, because obviously GC is something that people obviously want to see a lot of logging messages about, that now uses the unified logging API or logging method as well. Few specialized things that are being changed in JDK 9. Right. First one of these is a thing called spinningweight hints. This is a single method which is being added to JDK 9. We are very proud of this at Azure because we are the company that submitted the JSR, no, sorry, not the JSR, the JEP, the JDK enhancement proposal for this, and it's the first one that's been accepted by Oracle from people outside of Oracle, so I think we rock. In terms of what it does, it adds one method to the thread class. So it is a fairly significant thing. You've got to be careful when you add methods to the thread class because lots of people use the thread class. What it does is it adds on spin weight, and this is designed for people who are looking at very low-level performance of their applications, and if they think that their application is going to be in a processor spin loop, where the processor is actually spinning for a certain amount of time trying to acquire a lock, then you can actually put this method into your code to hint to the JVM that this is what's going to happen. If the JVM supports this and the hardware underneath supports it as well, then it can do some things to improve performance of your application. So it can, if we look at things like the disrupt pattern from LMAX, then this does actually benefit quite a lot from this particular piece of code. Variable handles. Variable handles are being introduced because of the encapsulation of the private APIs in JDK. So lots of people use sunmisc unsafe. And one of the reasons they do that is to get better performance. One of the areas that they tend to use this for is to enforce ordering of memory-specific operations, but also ensuring that operations happen in an atomic way so that you don't get different threads sort of messing about with the way that your code is working. Now, you can do that with the classes which are introduced in the concurrency utilities. So there's an atomic class, you can do atomic operations through that, but it's quite heavy in terms of overhead. So for people who are really trying to get down into the very, very low level performance, they use sunmisc unsafe, and they use the memory fencing and atomic operations. So what variable handles, or var handles, are about is introducing a public API that supports part of the now encapsulated private API provided by sunmisc unsafe. So you can get a var handle using the method handle lookup way of doing things. Once you've got a reference to a variable handle, you can do things like compare and set, compare and exchange, atomic operations. You can do get and add, get and set, and you can also put fences around your operations so that you can say, right, I don't want the JVM or the processor reordering these operations to try and improve efficiency. I want them happening in this particular order. Talking of method handles, there are some enhancements to the way method handles work. Most people, I'm guessing, probably don't use method handles a lot, but if you are using method handles for, especially if you're doing code where you're working on languages other than Java that are being compiled into bytecodes, then some of the things that are being introduced here are quite helpful. So there are low-level primitives to enable you to do easier way of handling loops, easier ways of doing try-finally blocks, and then how you do arguments for method calls. So that's about what's called argument spreading, so taking a group of arguments and separating them out, collection where you do the opposite of that, and folding when you take part of your set of arguments and you kind of fold those into one argument. So low-level things, again, most people won't actually have too much issue with those. A couple of smaller features. Nice one, actually, is the compiler control. Now, this is not control of the Java C compiler. This is control of the compilers that are used internally in the JVM, so the things that compile your bytecodes into native instructions. So there's C1 and C2 are the two compilers that are used by the JDK. And what you can do is you can actually set up a file which will allow you to specify certain things about how those compilers work. So you can give directives to the compiler when you start up your application. And you can also change some of those things at runtime via the J command. There are some changes to the process API. This has been around for a while, but what you can now do is get more information and more control over native processes. So there's a new class which is a process handle, which allows you to look at the process ID. You can look at who the user was, who owns that process, when it was started up, what command line arguments it had, things like that. You can also control the processes in terms of saying, right, I want to terminate this process, I want to terminate this process and any sub-processes that it has in that tree, various things like that. Obviously, those are subject to the control of the security manager, so you can't just go, oh, I'm going to pick on a process there and I'm going to kill it. That doesn't necessarily work. Only if you have permission to do so will you be able to do it. Housekeeping, things that are changing in that respect. Version string format. So this is one thing which may give you issues of incompatibility with earlier versions of Java if you rely on the version string being in a particular format and you process it in your application. Because it's not always as easy to tell with the version string of Java what it actually means, because there's limited update release, critical patch update releases, things like that. And when you see things like JDK 7 update 55 and JDK 7 update 60, and it's like, which has more patches? Well, you obviously think 60 has more patches than 55. You'd be wrong. 55 has more patches than 60. Don't ask me why. Also, we have this weird situation where you have a numbering scheme, one of which was designed by marketing, one of which was designed by engineering. And so you get JDK 8, update 121, and then you get JDK 1.8.0, underbar, U121. All very confusing and really needs to change. So now it does. So now we have JDK, which is going to be major number, minor number, security number, and a patch number. Much easier for you to understand because there's 4 numbers and you know exactly which each one means. So it'll be like JDK 9 dot, and then 1 or 0, security patch, and then patch, which is outside of the security patches. So it's easy to understand what it's talking about. It's also easy to parse that in terms of your code. So if you are using it, then it's more related to the idea of semantic versioning. Right. Time's up. No. I'm keeping going. I haven't got through all 55 features yet. Right, the file structure of the JDK and the JRE is changing as well. So again, if you rely on particular files being in a particular place, then you may have issues with that. The way things were before, you had the JDK directory, which had a bin directory, which had Java in it. Then you had the JRE directory, which had a bin directory, which had Java in it. So you had 2 copies of Java for the JDK, 2 lib directories, one of which had tools.jar in it, one of which had rt.jar in it. That's now a flat directory structure. So we have 1 bin directory, 1 copy of Java. We have a conf directory where all the files which you may need to make any changes in will go, so you know where those files are going to be. And the lib directory doesn't have any tools.jar or rt.jar file. It now has jmod files, which are the modules. In fact, no, lib doesn't have those. They're in mods. Lib has the native libraries that you need for your JDK. A couple of smaller features. Searchable API documentation. This is my favorite feature in JDK 9 by a long way. The fact that you now have a search box in the JDK API documentation, and you can just search for what you need rather than having to scroll all the way down. Because string is a long way down, and so when you want to find something like that, it's much easier. Annotations pipeline, that's just been improved. There's a version 2.0 of that, so you can now have repeating annotations of the same type, Lambda annotations, things like that. There's some redesign of the way that JavaC deals with annotations. Again, isn't really too important to average programmers. And there is a parser API for Nashorn now. General cleanup. So there's a few things like the SHA1 certificates are going away. Almost. There's a couple of places where they have to leave them behind because there are certain situations where they still need to be used, but theoretically they're going away. The applet API is finally being deprecated. Anybody still using applets? No. Okay, so that's probably a good thing then. Sadly, Tumbling Duke, no more. He's gone. Other things removed from the JDK. 6 APIs have been removed. These are 6 deprecated methods which have finally been removed. The first 6 in the history of Java. Add and remove action listener in the pack200 and log manager classes. So you think to yourself, well, what did they do that was so bad that meant those 6 and those 6 alone got removed? And the answer is that that was necessary to enable the modularization of the JDK. So there were some specific links that needed to be broken to enable it to be broken up in a simpler way. The JRE version selection command line option has gone away, so you can't use -version anymore, and a whole bunch of demos and samples that used to be shipped but which are well out of date have been removed as well. A couple of things in terms of ways you interact with the JVM. So the JVM TI hprof agent has gone away, only ever intended as a demo, but kind of got left behind. The JHat tool has gone away. That was only ever intended as an experimental tool, added in JDK 6, never been supported, and there are better tools available outside of the JDK. GC options have been removed, a group of these which are no longer tested. They may still work, but they're no longer tested, no longer supported. A lot of these relate to incremental concurrent mark sweep and some of the parallel new sort of combinations. If anybody's using parallel new and serial old, you really need to change that. Not for the reason that this is going away, but it's just not a good idea. Last thing I'm going to talk about is just briefly the idea of incubator modules, because this came up as something fairly recently, which is the idea of introducing new features to Java without making them part of the standard so that people can have a look at them, play with them, figure out if changes need to be made. I think this is quite a good idea because the problem is that when you get an API that's delivered, completed, and given to developers as part of the standard, it's very difficult to then go back and change it. And the chances are that for big pieces of functionality, you may not get the API quite right the first time. So by doing it through incubator modules, people can try it. They can say, okay, we don't like this bit, we do like this bit, change that. And then once it's stable and people like the way it works, then it can be moved into the standard. So that's the idea behind incubator modules. There's only one at the moment for JDK 9, which is the HTTP 2 module. Again, there's some concerns about fragmentation, but there are ways around that. So just to summarize, JDK 9 does have obviously the big new feature is modularity and Jigsaw, various different areas, modules, JLink, JMods, things like that. There are also quite a lot of smaller development features as we've gone through. So the new API for streams, the reactive API, the JShell, REPL, all of those are quite nice features that add things to JDK 9. Lots of standards, lots of performance work. Time to start testing. So if you're not already testing with JDK 9 on your applications, I would strongly recommend you to do that because of some of the changes that are coming with that. I will briefly use my second marketing slide. It's not really a marketing slide. We produce a version of the OpenJDK as a binary distribution. So we build the OpenJDK source code, and we then make it available for free. If you would like to talk to us about a support contract, very happy to talk to you about that at a very reasonable price. You can download it from zulu.org. We support older versions, so we do 6, 7, 8, and have early access versions of 9. We take the bug fixes which are made available for JDK 8 and we backport them into JDK 7 and JDK 6, and then we upstream those fixes back into the OpenJDK. So we are nice open source people. We make sure everything gets put back. And with that, I have I actually have about 3 minutes for questions. So if anybody's got any questions. Stunned silence. Oh, question at the back there. I think we're going to try and get a microphone to you.
Hello, I have two questions. First of all, what is the reasoning behind removing version parameter from Java, and is there any replacer for it?
Sorry, is the question was removing the version parameter from?
Yes, yes.
It was just that it didn't really, as far as I know, it didn't really ever sort of work that well. So it was the idea of trying to use an older version on a newer version, because the version number is picked up from the class file anyway. So specifying it on the command line doesn't really make a lot of sense. So I think the decision was just made to take it out so it didn't cause more support problems for the developers.
But it was quite a default way to actually check if Java is alive in many cases.
Oh, I see what you mean, yes. Well, you can now use, you can use help.
I see, thanks. And the second question, I doubt this information is correct, but I was told today that actually Jigsaw is kind of removed from Java 9 and will not be present. Is it true? Is it not true?
No, that is definitely not true. The reason I say that is because I was at the JCP meeting last week in Austin, so I know exactly what went on there. No. If you look at OpenJDK source code for 9, Jigsaw is in there. It was a big change, integrating the changes for Jigsaw into the source code tree for JDK 9. It's not like a set of class files you can just go, okay, well, we're going to take those out now, and we'll go back to what we had before. They're not going back. Jigsaw is in JDK 9. So whatever's released is going to have Jigsaw in it. As I say, the key thing with that was the fact that what the vote basically did was said, give the expert group another month to make some more changes to the specification to address the issues that people are having. Now, the expert group's done a lot of work in the 2 weeks during that vote to address a number of issues. So having another month is actually going to help them a lot. I'm very confident that when we get to the end of that month, things will be at a state where the people who voted no will go, okay, now you've done the work, we'll vote yes, and it will then go ahead as planned. It's just giving them an extra month to do some more changes.
Thank you.
Okay. Oh, one right at the back there.
What about the Nashorn engine? Will the ES6 support it in Java 9?
I don't believe so, no. I haven't seen anything say that. So I wouldn't like to say for certain, but I have seen nothing which said that ES6 was going to be supported in JDK 9.
Okay.
Okay. Right, I think I'm out of time, so thank you very much. Thank you very much. Thank you very much. Thank you very much. Thank you very much.